So when we say SDP is declarative, what we mean is that the developer only needs to specify the what of their data pipeline rather than focusing on the how. They define the data sets that they expect to exist and the queries that describe those data sets' contents, and the framework handles the rest. This is in contrast to an imperative paradigm where the developer needs to directly program the timing and execution of each processing step. This declarative approach isn't new or radical. You're likely already using it in your infrastructure and workflows today. Spark actually already made a big jump towards being declarative 10 years ago when it introduced Spark SQL and data frames. Spark SQL and data frames are declarative at the level of individual queries. Your query or data frame describes the data that you expect to exist, and the Spark engine is responsible for building a plan for how to produce that data. However, as soon as you wanted to write more than one query, you'd be on your own to figure out the execution plan. Spark developers have still needed to think imperatively when building a data pipeline. They've needed to write scripts to manage how each of the queries in their pipeline runs. Start this stream, wait for that table, retry if this fails. SDP changes this. It allows you to describe what you want, the tables and the data flows, and lets the framework figure out how to execute it, effectively extending Spark's declarative power from the query level to the entire pipeline level. A core benefit of this declarative model is that it enables a deep, holistic understanding of your entire data pipeline before it starts executing anything. This deep understanding allows uncovering many errors early that you otherwise wouldn't be able to find until much later. So it analyzes each query and then uses the result to determine what columns and data types are expected to show up in the table that the query populates. It then uses that result to analyze queries that read from those tables and make sure they'll be able to execute successfully. So this cascading analysis approach ensures that everything matches, that upstream tables contain the columns and data types that downstream queries expect. This pre-validation step provides immediate feedback on whether the pipeline can run successfully, instead of you having to find out after a bunch of queries have already been executed, which can be very expensive and time-consuming. SDP also handles state management. So in imperative Spark, you have to manually specify checkpoint locations to manage streaming data, but SDP automatically assigns and manages the checkpoints for streaming tables, treating state as an intrinsic part of the pipeline. And then SDP also manages parallelization. So to run independent steps simultaneously in a standard script, you have to write fragile Python multi-threading code. But this SDP graph analysis step can automatically do this parallelization for you.